Hey folks, welcome back to another video. Today we'll be looking at question 1091, shortest path in binary matrix. The way we will be approaching this problem is by using DFS, so let's jump right in. The first thing that we need to initialize is the directions in which that we need to travel. So the 2D array that you see right here would give you all of the directions moving one step up, down, left, right, and in all of the other diagonal directions. So once we have this, let's get the number of rows and columns that we have. So int r is equal to the number of rows, and int c is equal to the number of columns. Right. So once we have this, let's look at the base condition, right? So we need to check that the starting cell and the ending cell, they both are open. So rid of 0, 0, which is the position that we're starting at. You want to make sure that it is equal to 0. So if either of them are equal to -1, you would just return -1 since there's no path. So let's quickly do that. If it is equal to 1, you would just return -1. Awesome. If we haven't reached the base case, we actually go through the computations, and there are a couple of things that we need before we do that. We need a 2D Boolean array that keeps a track of all the cells that we have visited so far. So let's just initialize that really quickly, of the same size, of course, of size R and C. Next up, we need a queue that keeps a track of the cells that we need to visit immediately after. So that would be, and since it has to keep a track of the cells, so that would be the type of data that you're storing in there would be an int array. So linked list, right? And since we're starting off with the first cell, we add that to the queue. New int. And we also mark that cell as visited equals true. Perfect. All right. So the loop that will keep this entire solution in check would be a while loop that keeps checking if the queue is empty or not. As long as the queue is not empty or the condition hasn't been met, we keep looping through that. And in the while loop itself, let's get the size of the queue. And the reason why we're doing that is because within this while loop itself, we will keep adding new cells to the queue, but you want to make sure that within one iteration, you only go through the cells that have been previously added. So that's the reason why you have that, you get the size of the queue and make sure that you run only those many times. So I is less than size in this for loop, and you increment I. What's next? Right. So you actually get the current cell. Queue.poll. Right. So what's next? And then you check if current, so the x coordinate of the current value that we're looking at, if it is equal to r minus 1, and if it is the y value is equal to c minus 1, which means that we have reached the end of the maze, we would just return the number of steps that we have. Oh, that's something that we have to initialize, +1. So this also, let's say that in steps is equal to 0. And in each, after each loop, we would keep incrementing the number of steps that we have. Right. So, and the reason why we have a return steps +1 is because since we're incrementing steps only at the end, and we have reached the destination at that particular iteration, it wouldn't reach this if you want to return something right here. So we just increment it right there and return it. Right. So once we have that, if we haven't met the end condition, you look at the neighboring cells, and for that you need to iterate through all of the neighboring cells. So let's initialize that to s, s would be less than 8, and you increment s, and then you have int x equals current of 0 plus d of s of 0. So what you're doing here is that you're looking at the current x value, and then you're just adding whatever value that you need to take to get to the neighboring cell. So you need to do the same for y as well. Right. And once we have the new x and the y values, you need to check that they are within constraints, which means x is greater than or equal to 0, and x is less than r, and y is greater than or equal to 0, and y is less than c, and y hasn't so the grid value of x and y is equal to 0. That means it's actually empty, and then we can travel through that, and it hasn't been visited before. Y. Right. Perfect. So if all of these conditions are met, you will add that to the queue, and you will mark that particular cell as visited. Perfect. So that's actually the entire problem. You just need to make sure that at some point, if you haven't returned the result, that means there are actually no way to reach the endpoint, so we just return -1. All right, so let's quickly compile this and see if it runs. All right, so the first test case passes. All right, the second test case, everything else passes as well. Awesome. So let's quickly talk about the space and the time complexity. The time complexity is of n square, where n is the length of the grid. So you could also possibly say O of n itself if you're considering n as the number of cells, and the space complexity would also be O of n if n is the number of cells that you're considering, or it would be n squared if you're considering the length of the grid. And the reason why that is because at some point you could possibly have all of the cells in the queue depending on the size, and there's a reason why it's the space and the time complexity is of n. Awesome. So if there are any questions, please let me know in the comments below. And please don't forget to subscribe. I would really, really appreciate that. I'll see you all in the next video. Peace.